Hello and welcome to another how-to video of Infor's PLM Discrete version 10.2. I am Brian Rockwell, PLM Solutions Architect at Rockwell Consults. Categories have the ability to add fields and data for searching not typically found on an item or component. These fields are somewhat fluid in that one component type might have different requirements and/or data than another. For this reason, categories can be very powerful if set up correctly. This video will step the user admin and engineering department through the various pieces that are necessary to create the needed data and configuration. In order to accurately and precisely create categories, the information and data need to be analyzed in a regimented fashion. Since every company will interpret data in a different manner, this is more of a guideline than a specific process. The actual process is driven by the data review and how they are segregated in logical sections or divisions. Since PLM is so flexible, there are many cases that are specific to your organization that can truly benefit from careful and thoughtful planning. Conversely, it is very easy to create a system that is either unmanageable, confusing, or both. For these reasons, it would be wise to review. With that said, how can one determine the best approach? This video will not be able to answer that, but with a few examples, you might be inspired to follow basic guidelines. The most common and one of the most logical for a manufacturing facility dealing with electrical and mechanical components is to separate them accordingly. You will see how electrical components are separated by component type, such as resistors, capacitors, coils, transformers, integrated circuits, diodes, LEDs, etc. On the other hand, you will do the same for mechanical components and split them according to their components as well. Hardware may fall into categories such as screws, bolts, nuts, washers, flanges, O-rings, etc. There are industry-specific inventories that also could be used. Some of the industries noted are broad enough that their selective inventories might be found with a little research. If categorizing still seems nebulous and further support is required, Rockwell Consults can assist in the development process. For process manufacturing like food and beverage, petroleum, chemical manufacturing, and pharmaceutical industries, a process PLM package such as Optiva might be more in line for what you do. A link for more information is found at the bottom of the screen. So, now that we have identified the category tree of what will be seen as the divisions, the next step is to add the actual data requirements to each branch, as they are called. Each division will require some fields or attributes that define that particular segment. In the example above, we can use a screw as a branch and determine what it is that we need to define for each and every screw that will be used in our inventory. It is not necessary we define every single detail, just make each screw type stand out from others so it is searchable. Remember that searching is the ability to find information that is pertinent and limited and in the least amount of time. If I had the screw description as displayed, this would be something I would want to describe in the easiest, most logical manner possible. Not only so that others could find it, but also so that by reviewing the results, the user is absolutely sure they have exactly what they want. Now, if their search criteria are not as precise, they might receive a selection of items that would fit, requiring them to select from that list. As long as that list is the maximum of 5 to 10, that is usually sufficient. Beyond that, and the search would need to be refined. Using the current example, I would want to set up the attributes for the screw in this manner or something similar. The characteristics or properties would then fit into the specific attribute fields. In PLM, let's set up each of the attributes based on this screw. We can see that other screws will also fit into the pattern, so this is not a unique part. First, we open the category management from the admin role in PLM. We are concentrating on items, therefore we will select it as well. From here, we will set up the category tree with the various classifications of mechanical, hardware, screws. Each has its logical category level within the confines we have determined. One note here is that if you create a particular attribute at a higher level than the lowest branch, it will appear in all the children branches. This can reduce retyping attributes that are common to certain groups of categories. Now that we have created the tree, we will go ahead and create each of the attributes. If you notice, there are several types of attributes that can be made. To describe, the following are options for the attribute. Measurement allows you to affix a unit of measure with the value, whereas number does not. A list is very common when it will reduce input from the user creating new parts, and text is simply a string of information. When selecting, there is a character limit on the length of the string that PLM admin will need to define. Date is mostly self-explanatory, however it is good when indicating, for example, when the part was created, or if there is an associated spec sheet and the date it was issued. Boolean is a simple yes-no, true-false indicator. If this is something that is yes, no, or maybe, it would be better to create a list attribute and enumerate the options. As we create the different attributes, as you see here, the options are to label the attribute, select the attribute type, the length of its text, whether the attribute is mandatory, and who can update the information. The Update Access field indicates whether the user can update the value from within PLM, meaning internal, from some external source, such as CAD, meaning external, or if there are no restrictions, or general. There are other fields also available, but are reserved for specific types of attributes and conditions that are specific to those attributes. I will continue creating the different attributes and fast forward to the one that is most relevant to these additional fields. Since I need to set the length of the screw, I will create an attribute called length with a type of measurement. From here, I will set the group to length and then select the unit of measurement to define that number value. Because I need to create an attribute with a unit of measurement, I will select the measurement type attribute. What this does is expose the group and unit of measure fields, allowing me to select from the predefined units of measurement in PLM. The UOM group is to classify the different unit of measurements, such as feet, inches, and meters, to be considered length. Here I search for the correct group, which in turn limits my unit of measure only to length options. Now we reach a limitation to the software. We can only select one unit of measurement type and cannot select from a list of available options. Therefore, metric and standard screws cannot both be managed from within the same attribute. The workaround Rockwell Consults created was to simply ignore the measurement type and create a number attribute for the value and a list attribute for the unit of measurement. This allows both to be used simultaneously, although it does allow the engineer to input a metric value and select an English unit of measurement Now that we have configured the system, let's create the screw we want in inventory. We do so by creating the item in PLM, then select the ellipsis next to the category name. This causes a pop-up window to display with the category tree on the left and the window on the right to show the attributes. We will select the screw branch from the tree, then fill in the information on the right. If the user has too much leeway in creating descriptions, you will open yourself to having interpretations of the same value. For example, I could potentially call half an inch as 0.5 with double quotes, or 1/5 space IN, which, although both may be valid technically speaking, searching for either would result in the lack of any written the other way. For this reason, the more limitations you can place on the manner data are stored will significantly affect the way data are found. Once complete, we close the category widget by selecting OK. To search on the screw we want, we need to open the advanced search and select New. We open the item and expand the categories. I added a few additional screws to help provide some idea of how we can limit searching to specifically what is desired. As you see, I can be as vague or verbose as I can, and each time will limit the results based on my selection. As you can see, I can select the screw type, and from there I pretty much receive almost everything back from what I had from before, because they're all considered screws. But as I begin to refine my searching, it becomes evident that my search criteria shrinks dramatically once I become more specific in what I am looking for. So I'm going to remove this one criterion because it was a little bit too specific, and I'm going to show that by selecting a length of 0.5 inches that I have 3 of my screws that are half an inch long, and one of them is a nylon screw. The other 2 are steel. One was stainless and one was regular steel, I believe. So I need to now shrink that down as well, and then go ahead and select my material, and now I'm down to exactly what I was looking for, the one screw that I wanted. For more information about other how-to videos, you can subscribe to our YouTube channel. To learn more about Rockwell Consults and how we can improve your manufacturing processes and data management, go to rockwellconsults.com.